So this is the data given of 440 volts, 3-phase, 8 poles, 50 hertz, 40 kilowatts, star connected 3-phase induction motor has the following parameters. Stator resistance 0.1 ohm, stator reactance 0.4 ohms, equivalent rotor resistance referred to stator. Okay, so already is giving. So equivalent rotor resistance referred to stator. So this is nothing but your R2 dash. Okay, so R2 dash is giving. Next, rotor equivalent rotor reactance referred to stator 0.44 ohms. Stator core loss is 1250 watts. So the stator core loss, what is giving, it is for the whole system, that is for 3-phase. So if we want to find the no load losses per phase, so that has to be divided by 3. So while mechanical losses is 1000 watts, it draws a no load current of 20 amps. So I0 is giving us 20 amps at a power factor of 0.09 lagging. So no load current which is lagging at a power factor of 0.09 value. So while running at a speed of 727.5 RPM. So that is N is giving. So 727.5 RPM. So calculate. So input current and power factor. Next, torque developed, output power and efficiency. So use approximate equivalent circuit is telling. Okay. So here, if we go for the equivalent circuit, just I'll go for the equivalent circuit just for our recall the formulas. Okay. So this is the equivalent circuit which is referred to the stator. Okay. So when we are referring to the stator, so then the current, that is the secondary side, that is rotor side, the values, parameter values will change. Suppose if it is referred to rotor, then the stator parameters will change. Okay. So here R1 will be R1 dash, which will be equal to K into R1. So here, since it is referred to stator, so R2 dash will be equal to R2 by K square. So K is nothing but the transformation ratio. So similarly, X2 dash will be equal to X2 by K square. So already this value is given. So equivalent equivalent rotor resistance referred to stator already has given, and similarly equivalent rotor reactance he has given referred to stator. So X2 dash he has given. So similarly, so he is giving the losses for 3-phase. So now we have to find, so what are the input current, so torque developed, next output power and efficiency. So to find the current, that is input current I1. So I1 will be equal to the sum of the no load current and the rotor current referred to stator. Okay, that is I2 dash. I2R dash is your input current, that is stator current I1. So I0 already has given. So I0 is equal to 20. So cos, that is angle we have to find. Power factor has given. We have to find the angle. So have your material with you. Now I1 will be equal to I0 plus I2R dash. So I0 is equal to 20 at an angle cos inverse of 0.09. So calculate how much you will be getting. I0 20 at an angle minus you take. So minus why? Because it is lagging. Minus cos inverse of 0.09.
Minus 8.84, sir.
Minus,
I mean 84.84.
Minus 84.84 is the angle. So now I0 is equal to 20 at an angle minus 84.83 is the no load current. So convert that to rectangle. So in terms of J, how much are you getting?
Sir, 1.8 minus J 19.9, sir.
Yeah. So 1.8 minus J 19.9,
9, sir.
19.9. Okay, fine. So that is the conversion. So now what is I2 dash? So I2 dash will be equal to V1 divided by R1 naught plus RL dash. Okay, plus that is J of X1 naught. So that is referred to stator. Okay, so what is V1? So V1 he has given as line voltage. Line voltage he has given as 440 volts. So convert that to per phase. So V1 will be equal to VL by root 3. So 440 divided by root 3. How much are you getting?
254.03, sir.
Okay, 254.03 is your input voltage. That is phase voltage. Okay. So now we require what is the rotor resistance referred to stator, which will be equal to R1 plus R2 dash. Okay. So what is the value of R1 he has given? So R1 he has given as rotor the stator resistance 0.1 ohms, and R2 dash already has given equivalent rotor resistance referred to stator, that is 0.15 ohms. So find what is the R01. So you will be getting 0.25 ohms.
Yes, sir.
Okay, so similarly X01 or X1 naught, which is equal to X1 plus X2 dash. So X2 stator reactance. So stator reactance he has given as 0.4 ohms, and equivalent rotor reactance referred to stator is 0.44 ohms. So then it will be equal to 0.84 ohms, right? 0.4 plus 0.44. So 0.84 ohms. Done?
Yes, sir.
Okay. So now find what is RL dash. That is load variable. RL dash is equal to R2 dash into 1 minus S divided by S. So we don't know what is the slip. So find slip. So to find slip, we must know synchronous speed. So NS is equal to 120 F by P. So frequency is 50 hertz. Number of poles are 8. So find synchronous speed. So if it is 727.5 means it will be
750,
750
sir.
RPM. So NS is 750 RPM. So now find what is the slip. So 750 minus 727.5 divided by 750. How much are you getting?
1 second, sir.
750 minus 720, almost 3% you will be getting. Are you getting 0.03?
Yes, sir. We're getting, sir.
Okay. So now substitute in RL dash formula. That is R2 dash. Already we know. That is 0.15 is R2 dash into 1 minus 0.03 divided by 0.03.
0.35, sir.
Which one?
RL dash.
No. You must have the calculator. I don't have the calculator. So 1 minus 0.03.
Sir, 4.85, sir.
0.03 into 0.15, right?
Yes, sir.
4.85 is the resistance. 4.85 is the RL dash. So now substitute in current equation, that is the rotor current equation, referred to I2R dash is equal to V1 divided by R1 naught plus RL dash plus J X1 naught. So substitute, find what is I2 dash. So get the answers in both rectangle form as well as the polar form.
Sir, 49.81 plus J 0.84, sir.
Pardon?
49.81 plus J 0.84.
No. You must add that two resistance. That is 0.25
Plus 4.85.
plus 4 point. Then you must add plus J 0.84. So denominator, if you convert to polar rectangle, polar. So what is the value you will be getting? Sorry, rectangle. It is already in polar. If you convert to rectangle, what is the value you will be getting? So 0.25 plus 4.85 is
Sir, this JX10 is in denominator numerator, sir. JX1 not.
pardon?
JX1 not, sir. Is it in denominator numerator, sir?
No, denominator.
Oh.
So this will be whole value.
Okay, yes, sir. Yes.
Impedance, no, current will be equal to
Sir, 48.49 minus 7.99 I. J.
yeah. So that is converting to rectangle. So polar will be 49.14 at an angle minus 9.35. If you convert to polar to rectangle, so the value will be 48.49 minus J 7.98.
Yes, sir.
Correct?
Yes, sir.
Okay, fine. So now we know the current value. Okay. So now substitute in the first equation, that is I naught plus I2R. So both must be in rectangle form. So 40 I naught is 1.8 minus J 19.91 plus 48.49 minus J 7.98. So add the real and imaginary part. So since both are minus, so it will be in minus only. So we'll be getting current I1 is equal to 50.295 minus J 27.9. Are you getting?
1 second, sir. So 50.29 minus 27.89 J.
Okay, fine. So convert that and you'll be getting 57.51 at an angle minus 29.0 some value.
$57.5 at an angle of
Yeah,
minus 29.012, sir.
yeah. So that is your input current. Okay. So
Yes.
input current I1 in magnitude will be equal to 57.51 amps, and the power factor will be so cos of 29.01. You see how much we'll get. Cos of 29.01.
0.87, sir.
Okay, so 0.87 lagging. Okay, since we are getting the angle as negative, so it will be in lagging. So next we have to find what is the torque developed. Okay, so to find the torque developed, so we can go for this formula. That is P2. So P2 will be equal to whatever the formula. So with respect to omega s, P2 is equal to P into omega s. So what is P2? So P2 is the rotor input. So rotor input will be equal to, so as per the formula, it is 3I2 dash square into R2. Okay. So the formula has been represented here. So you can go for this formula. So P2 is equal to torque into omega s. So torque is equal to P2 by omega s. So P2 is equal to 3 into I2R square into R2 dash divided by S divided by omega s is equal to 2 pi ns by 60. So substitute in this formula. So find what is the torque. So we'll be getting the torque.
Sir, can you repeat the formula, sir? We are seeing in phone, so it is not big, sir. Can you repeat the formula, sir?
Okay. So P2 is equal to
Yes, sir.
the product of torque into omega s, angular velocity.
Yes, sir.
Okay. So we have to find torque. So T is equal to P2 divided by omega s.
Yes, sir.
Okay. So P2 will be equal to, since it has been referred to stator, the slip comes into consideration. Okay. So with respect to that, P2 will be equal to 3 into I2R dash square into R2 dash divided by S. So that is the
Okay, sir.
P2.
Yes,
So
sir.
find what is the P2 value. Since it is three phase, we are multiplying by 3. So you know I2R dash, R2 you know, slip we know. So find P2. So you'll be getting around 36.23 kilowatts. The current is 49.148. That is I2R. dash into 0.15 divided by 0.03. Are you getting 36.23?
No, sir.
You're not getting.
No, sir. I'm not getting 36.23.
36 point. So look here. So your formula is P2 is equal to 3 into
Yes, sir.
what is the current I2R dash? I2R dash, that is in which form? That is in the polar form. So polar form will be 49.148.
Yes, sir.
So 49.14 into, that is square. R2 dash is 0.15, right?
Yes, sir.
So divided by slip is 0.03. Okay, so you're getting 32.59 kilowatts. Is it correct?
So no, sir. We're getting 36.23, sir.
36.23.
23. Once again, sir. I'll cross check one last time, sir.
49.14 into 49.14 into 3 into 0.15. This R2 dash is 0.15. This divided by 0.03. 36.22 you're getting.
Yes, sir.
Okay. So that is your P2, that is rotor input value.
Yes, sir.
Okay. So as per the diagram, if you see, P2 is the rotor input. Okay. That is the stator output.
Sir,
So
here,
now,
why don't we consider the angle, sir, for I to R dash?
pardon?
The angle, why don't we consider, sir, for I to R dash?
We don't require the angle. So power factor will not come into consideration here. So only we will be considering the magnitude value.
Okay, sir.
So wherever we go for whatever the voltage or current equations, so there we'll go for means to find the impedance or to find the voltage or to find the current, we require the power factor. So when we go for finding the torque, when we go for finding the power and all, okay. So generally, power factor will be added when you go for power. So torque will not depend upon the power factor. Okay. So that's why we'll not go for considering the power factor. We'll go for only considering the magnitude values. Okay. So
Yes, sir.
next, what is omega s? Omega is equal to 2 pi ns by 60.
78.5, sir.
So omega s is 78.5. So now you divide these two values.
We're getting 0.46, sir.
0.46.
Yes, sir. 36.23 divided by 78.5.
36.23, it is in kilowatts, right?
Yes, sir. So this. Uh,
It is in kilowatts. So then it will be kilonewton meter. So 0.46 kilonewton meter or 461.33
0.53.
Newton
Yes, sir.
meter.
Yes, sir.
That is the torque. Uh, that is the net torque which will be found for the required. So it's telling torque developed. Next, we have to find what is the output power. So to find the output power, so here is the formula, that is P2. So we have to find what is the rotor copper loss. We have to find what is the mechanical loss. And he is giving the data. Okay, so core loss is given. So what is the core loss is given? 1250 watts. That is stator core loss. Next, mechanical loss is giving as 1000 watts. So here, by using this formula, so find what is PM. So to find output power, so we require motor mechanical power. So to find the mechanical power, so P2 by PM. So P2 by PM, which is equal to 1 divided by 1 minus S. So already we know P2. So PM will be equal to 1 minus S into P2. PM equal to 1 minus S into P2. So already we know what is the value of P2.
2.54 kilowatts, sir.
This one, PM.
PM, sir.
Okay. You must get more, no? So why? Because 1 minus 0.03.
0.07, sir.
1 minus 0.03, 0.97 into 36.23.
2.3. Yes, sir.
So 35.14 kilowatts. Check once again.
Sir, 0.07 into 36.23 kilowatts, no, sir.
Point?
0.07.
0.97 alvenappa. 1 minus 0.03.
Oh, yes, sir. Yes, sir. Yes, sir. Sorry, sir. 35.14, sir.
Okay, 35.14 kilowatts.
Yes, sir.
Okay, so now total output power P out is equal to PM minus mechanical losses. So PM is 35.14 minus 1000. So it will be 34.14 kilowatts.
Yes,
That is
sir.
the output power. Okay.
Yes, sir.
Okay. So now let us go for finding the losses. Okay. So core loss he has given us 1250. So mechanical loss is given as 1000. So find what is the total copper loss. So to find the total copper loss, the formula is 3 into I2 dash square into R1 naught. So that is the stator plus rotor losses comes into consideration. So 3 into I2 dash square into R1 naught. So that is 3 into 49.14 square into 0.25. So we'll be getting around 1811.67
Yes, sir.
watts. So now the total losses will be equal to, so 1250 plus 1811.6 plus the mechanical loss is 1000. So total loss will be equal to 4061.6 watts. So now find efficiency. So efficiency is equal to output power by input power. So input power already has given us 40 kilowatts. Or you can go for P out divided by P out plus total losses.
%, sir.
89.36 ಬರ್ಬೇಕಲ್ಲ.
Sir, 4061.6 by
P out is 34.14 divided by output power plus total losses. Output power again 34.14 plus if it is in kilowatts. So kilowatts, if you take 34,146 divided by 34,146 plus 1,250 plus 1811 plus 1000.
Sir.
So once again, I'll repeat. Output power we have found as 34.146 kilowatts divided by input power. So input power is nothing but output plus losses, total losses. So output again 34.14 plus 1.25 plus 1.811 plus 1.
Yes, sir. 89, sir.
So 89.36.
37, sir. Yes, sir.
Okay, 37% is your efficiency. So this is how we'll be solving when the equivalent circuit parameters has been given. So with respect to that, we'll be finding what is the efficiency, torque, the rotor losses, and input current and the power factor. So similarly, so this is the another numerical. So here is giving the stator impedance, so resistance and reactance. So voltage is giving as 500 volts, three-phase star connected. The equivalent rotor impedance at standstill is same. Okay, so here the standstill values is giving. The magnetizing current IM is giving as 36 amps. The core loss is 1500 watts and mechanical loss is 750 watts. Find the output efficiency and power factor at a slip of 2% is telling. So now with respect to this, so core loss is giving here. So the core loss whatever is been representing, it is for three phase. Okay, so convert that for single phase. So divided by 3, so we'll be getting 500 watts. So now from here you find what is the IC, that is working current, because he is giving magnetizing current here IM. So no load current he has not given directly. So you have to find what is the no load current. No load current I naught will be equal to IM plus whatever the IC value. So to find IC is giving this losses, core loss. So core loss per phase will be equal to 500, which will be equal to IC square into R naught. Okay. So to find R naught, so we have to go for with respect to whatever the value he has been giving. Okay. So since R naught is not able to find, so there is one more formula according to Ohm's the power formula. P is equal to V into I. So that is V1 into IC. So V1 we can find. V1 he has given as that is line voltage he has given as 500. So convert that to phase. So if you convert that to phase, so divide by root 3. So you'll be getting some value from
288.68, sir.
how much?
288.68.
288.68 is the voltage per phase. So now with respect to that, so find what is IC. So IC is equal to, so whatever the 500 divided by, so 288.6. So we'll be getting IC. That is working current or compensating current, which will be equal to 1.732 will be getting.
Yes, sir.
Okay, now if we add 36 plus 1.732, so that we will be getting, the magnitude value. Okay, so but directly we cannot take the magnitude, so we have to go for the angle also. So we must find what is the power factor. Okay, so to find the power factor, so then 30 magnetizing current will be the imaginary part, IC will be the real part. So 1.732 minus J, what is it, 36 minus J 36. So there you will be getting the I naught value as 36.04 at an angle minus 87.24. So why minus? Since it is lagging. Okay, so it is an induction motor. We'll be using the inductive coil. So whenever we use the inductive coil, the current will always be lagging. Okay. So once if you find I naught, got it? Any doubts here?
No, sir. No, sir.
Okay. So once if you find I naught, next go for finding I2R dash. So again I2R dash will be equal to V1 divided by R1 naught plus RL dash plus J X1 naught. Okay. So with respect to this, is giving the data, that is this value is giving. So 0.62 plus when you go for rotor, again it is 0.062. Okay. So then R01 or R10 will be equal to 0.124 ohms. So similarly, X1 naught will be equal to X1 plus X2 dash. So X1 already is giving us 0.21 ohms. Again, you add the same 0.21 ohms. Okay. So then which will be equal to 0.42 ohms. So now substitute in the equation. Okay. So before substituting, we must find what is RL dash. So again, RL dash is equal to R2 dash into 1 minus S divided by S. So RL dash will be equal to R2 dash. R2 dash is equal to 0.062 into 1 minus percentage slip he has given us 2%. It will be 0.02 divided by 0.02. So RL dash will be equal to 3 ohms. So 3.0 some value will be getting. So 3 ohms will be your RL dash. So substitute and if you find I2 dash will be equal to 90.5 at an angle minus 7.566 amps you'll be getting. So now if you add, convert this and if you see, you'll be getting 89.71 minus J 11.9. So if you add both the currents, so the input current will be 91.44 minus J 47.91. So if you convert that into other form, so it will be 103.27 at an angle minus 27. So power factor will be cos of 27.65. So it will be 0.88 lagging. So similarly, you can find what is PC rotor copper loss. So rotor copper loss 3 into I2 R square into R2 dash. And again, you can go for this formula. He is not telling to find the torque. So rest of the other data you can find. Got it?
Yes, sir. Yes, sir.
Okay. So follow the same procedure. If you have any doubts, you can ping me individually. So I'll answer for your doubts. Okay. So
Okay, sir.
tomorrow, please have the graph sheets, compass, pencil, scale with you. So tomorrow I'll go for no load and block rotor test of a 3-phase induction motor and circle diagram. Okay, the procedure how to draw the circle diagram. Okay.
Yes, sir.
Okay. Thank you.